Hey guys, we're looking at your Khan Academy homework of proving triangle similarities. We're looking at a proof here. We're going to try to go through 2 examples together in this video so you can watch along, reference the recordings while you're working on your homework. All right, let's see what's happening. Let's dive in. I know looking at this, we're feeling a little stressed, but it's going to be okay. Proofs, I promise, are not too bad. You're really just like I like to think of it as like you are explaining this to maybe a younger sibling or a friend that's not in your class, and you're like just being super slow, basic. This is every step of how we worked this out. That's all you're doing is you're just showing your steps and explaining how did you know that was correct? How did you know that that's true? Okay, so with any kind of error analysis, we want to start by looking over what do we have here? What's going on? Looking over their work, and if we're not able to find out the mistake right away, then we want to try this on our own. Sometimes it's also helpful to just, while you're looking at error analysis, to work on it on your own and kind of just compare and contrast. Okay, what did they do? All right, so let's see what's happening here. Rebecca was curious whether triangle STV and triangle WUV, so the big triangle versus the small triangle, are similar, so she wrote a proof and came to the conclusion that they are not similar, but her proof is wrong. Oh no. What is the first mistake that she made in her proof? Okay, so let's see. She said first, angle V is congruent to angle V. Before we actually dive into this, I think it's helpful when we have triangles like this where they're like, they're smushed together, they're overlapping. It can be helpful to remember when we're doing triangle proofs, we're zeroing in on 2 different triangles. Whoa, let me fix that. It's kind of slanted. Okay, so this is the big triangle. This is going to be the small triangle. And we're just going to annotate on here off to the side. Whenever we're doing proofs, very, very important, we are annotating, marking up our figure. Okay, so let's check. The first thing she said was that angle V is congruent to angle V because of the reflexive property, and I can agree with that, right? Angle V, no matter what angle V is, it's going to be the same for both triangles because this is where it overlaps. They share that angle measurement. So far this is looking good. Okay, I agree. Next, she went on to say, let me switch colors here, that side length WU over side length ST is equal to 15 over 22.5. And then rounded that up. Plugged in the calculator. Let's see. So she said substitute given values. Okay, so let's just double check that matched up. WU, yep, that was 15. ST, yes, was 22.5. Those were given on the figure. Okay. And she's saying, I like to do this as smaller versus larger. So she did smaller side length over larger to get that. Okay. This might be helpful for later on. We'll see. Next statement. I'll swap colors again. We've got side length VU and VT. Okay, so this is good. So far, she's matching the correct side lengths, right? She's not, sorry, we're color coding. She's not saying VU and SV, right? Like those weren't ones that matched up. So these are corresponding. And let's see what she said. VU is 10. And then VT, she said, is 5. Let's see. So VU, that is our smaller triangle. VT is our larger triangle. So already this doesn't quite make sense because isn't the denominator supposed to be the larger triangle? Isn't it supposed to be a larger number, right? If VU is 10, VT, look at that. That's a gigantic side length. It's much larger than 10. How is it that she only got 5? So this is already looking a little crazy here, a little suspicious. Okay, so do you have any ideas what this distance should be? VT? Encourage you to pause. Look at the figure. What information are they telling us? What is side length VT? Going from point V all the way to point T. It looks like we traveled for sure a distance of 10. That was looks a little crazy, a little messy. For sure a distance of 10, right? Because that's including side length VU. And then it's also including this little chunk here from U to T. So VUT, side length VT, it's 10 plus 5. This should be 15. So this might be her first mistake that she made, where we do not agree. That's supposed to be a 15. The denominator was incorrect. And then from there, she noticed, hey, they didn't match up, right? But let's check, would it match up? 10 divided by 15. Let's see what that gives us in the calculator. 10 divided by 15 is going to be 0.6 repeating. Hey, and that's what we got for the other side length. So because those matched up, they had the same ratio, the same skill factor, they would be similar. But let's not get ahead of ourselves. We have to figure out how to explain this, that this was the mistake in step 3. The length of side VT is not 5. Okay, that sounds right. Side VU does not correspond to side VT. No, it does. We found it does. Side WU does not correspond to ST. WU and ST. No, that was one that we checked off. I forgot to give it a check that it was correct. That one we checked off. Okay, so that doesn't work. Rebecca should have compared VU over VT, VU over VT with ST over WU. Let's what she did. I mean, she should have, done the complete VT, right? But that's looking at now step 4, where this comes into play. And while that was a mistake because of the VT, she had the wrong number, it wasn't the first mistake. So you want to know what the first mistake was, because this is also incorrect, step 4, right? But why was this incorrect? Because she had the wrong value. So the side length of VT is not 5. Oh no, it is not 5. It was supposed to be 15. She made a little mistake there. She just saw 5 floating. Was like, oh, that must be it, right? But we're like, okay, that's why we go slow with proofs. We annotate, we label, mark up. What are we given? What's going on? A V to T. Oh, okay, it was 15. All right, let's try one more together. Oh, this is a fancy one. This is a special one. We're gonna do the same thing, except this time we're not doing the same thing. My apologies. I assumed that this was an error analysis too. This is not error analysis. This is a normal proof. We'll be filling in the blanks. But remember, when we are working with proofs, we don't want to just dive in. That is a big mistake. Won't help us succeed. We want to go nice and slow, annotating, marking up our figures. Let's see what's going on here. Okay, so starting off, well, these triangles are already kind of split up, so I think I'll leave them. But I'm going to label this. This is the smaller triangle, little tiny baby small triangle. This is a larger triangle, much larger triangle. All right, so we're going to label it small and large to make sure that we're going to match these up correctly. Okay, SU, so they're going large divided by WU divided by small. So large SU divided by WU, 9 over 6 is 1.5. TU, again, large over small. The reason we have to label this, notice from the last problem, it was small over large. It doesn't matter which one you want to choose, how you want to do it, but you have to make sure that you are consistent, that we're not all of a sudden going, now we're going to compare small over large. Instead, we have to be consistent with this ratio, otherwise it's not going to work. All right, so that's why I'm just checking. Okay, so the order they're doing is large over small. Okay, and that's what's given. Cool. Next, pick a statement, and the reason is to substitute 1, 2. Okay, let's try to figure out what's going on there. Substitute 1, 2. Okay, so let's see. WU equals TU. No, that does not fit. We're talking about similarity too, so there shouldn't be anything that's equal. No side length should be congruent, should be equal. SU over WU is equal to TU over VU. That works. That's what was given. So substitute step one and step two. We're just plugging in what we got. All right. Because we just said, hey, look at that. Those are the same ratio. Huh. Interesting. And now, next step, step 4, let's see what's happening here. Angle TUS, TUS, this angle right here is congruent to angle VUW, is congruent to this angle right here. What could our reason be? Let's look at our options. Why could those be congruent? Was that given in the figure? Are they vertical angles? Or are they corresponding angles? Or is it because corresponding angles in similar triangles are congruent? So let's look at that again. This is where we're going to just zero in on that intersection. This angle and this angle. Hopefully this is ringing a bell. Wish they had a highlighter tool in Con. That'd be pretty cool. So it's giving us this hourglass shape. Hourglass shape. All right. It looks like vertical. Looks like a V for vertical and an A for angles. Vertical angles. Vertical angles are always congruent. It gives us a bow tie or a hourglass shape. These are vertical angles, and vertical angles are always congruent. All right. And with that, there is enough information to say the triangles are congruent. We need to pick the criterion. So let's compare contrast again. So we compared SU, I forgot to mark up figure, SU with WU. Those were corresponding side lengths. And then TU matched up was proportional to VU. Okay, so what are we given here? I see a side, I see an angle, and a side. We found a side that was proportional, we found an angle that was congruent, and another side that was proportional, so it should be side, angle, side. And let's check. Yay! All right, I'm not going to go through the last two with you. Try those last two on your own, but I hope this helps at least give you, a strategy, plan of attack on how to work through this on your own. Any questions at all? Again, please let me know. All right, take care. Bye.